proportional. Yesterday you didn't. I'm going to tell you straight off, basically every graph you get today is proportional. Our job is to analyze them. What are they saying in the graph? Let's start off with probably the most gentlest type of problem you'll see today. You likely won't have one of these on your test. This is more just informational. So this graph is showing you a few things. It's showing you the distance traveled by Mars rover Curiosity, which was a little robot who might still be on Mars, I'm not sure. And it's proportional to the time traveled. This little robot is very consistent. It does not change speed. It just travels across Mars at a very slow rate and takes some cool pictures. You're going to interpret what the dots mean. Let's start at 0, 0. The Mars rover lands and it's chilling on Mars. At 0, 0, it's not going anywhere at 0 seconds. It traveled 0 inches in 0 seconds. The x value is the time, right? Time above the first 0. The y value is distance. You're going to look at your graph and label the bottom part x. You run before you jump y. The bottom is always x, the sides are always y. Every graph you see, it will be that way. So let's tell them what this means. This means that at 0 seconds, the Curiosity rover traveled 0 inches. That dot told me that much. Go up to the second dot, 1, 1.5. At 1 second, run before you jump. Go over 1, then jump. How far did this thing travel, Justice?
15 inches.
It has a decimal in there too, kind of hard to see. It's 1.5 inches. Right there. Right there. Sorry. Last one that you're going to analyze, over 3. What does the 3 stand for, Sierra? Jackson, question? No? I thought you had a question. You were talking. Okay. Yeah, it's a little bit light. I'll clarify things. There's a few different problems that are kind of fuzzy. At 3 seconds, this thing travels 4.5 inches. Okay, so that's the information that we can gather from the graph. Pretty cool. What if they say 2y, though? They're asking you, in 2 seconds, how far can this thing travel? They don't tell you it. They want you to figure out what y equals. If you go over to the graph, run to 2, just by looking at this graph, you can get that y value by looking at the dots. Go over to 2, slide your pencil up. Where do you hit the line, Nora? At what point is y going to be across from that? It's at 3. So at 2 seconds, this thing travels 3 inches. We can say that y equals 3 inches. Cool. So that's the information we gathered. We're going to get a little more complicated. Yeah. Did it say 2.5? Right here. So let's go over to 2. 2.5 would be right here, Tessa. If you went up from 2.5, it would be about 3.5.
No, I mean, wouldn't y be 2?
I see. If you go across here, it's going to be at 3.
But if you go up 1, and you go across, it doesn't go.
Up 3 over 2. Do you mean this point? Oh, are you looking for k for the constant? The constant would be 3 over 2. Does that make sense? You went up 3, you went over 2. Up 3, over 2. This is the same thing. So 1.5 over 1 is the same as 3 over 2. Yeah. Make sense? Okay, next example. Keep going. Another type of problem you're going to see is the graph of a proportional relationship passes through a point, 3, 6, and 1, y. You're looking for y this time. How do I graph 3, 6, Max? Run and jump. Lead me on the path to get to that coordinate.
3 down at the bottom, 3 go up, so it crosses the 6 line.
Okay, great. If this thing is proportional, you're going to take a ruler, which I'll pass out in a second, and you're going to draw a line across the 0. The 0 point is the proportional relationship, so you're going to put a dot here. Make a dot at 0, 0. Connect those two as precisely as you can. I'm going to pass out rulers during bronze. You guys can just make a line look like that. Liliana? You could do that too. A proportion? Sure. If they give you a graph though, I want you to practice with this because I want you to analyze the graph today. They're looking for 1y. If you go over 1, you're looking for the y value that is at x1. Go up to the line and you're going to put a dot at this point. What's the y value when x is 1, Logan?
2 over 1.
This y value is 2. So the point you just found was 1, 2. Your answer for this thing would be y is 2.
Oh, yeah.
If you draw the line, you can go over 1, go up to the 2 at your points. Last example. Read this for me, please. Avery, this graph shows.
This graph shows the proportional relationship between the number of minutes and it takes back and operates the total number of cakes.
Aiden 2. Packing cakes is what this thing is talking about. You have number of cakes on the left, time minutes on the bottom. If you are looking at the point that they give you, they say the point right here is P. We're going to look at that thing and analyze it in a few different statements. They tell me that there's 3 things they want me to analyze. If it's true, mark true. If it's false, mark false. Point P, they say, represents the total number of cakes packed in 4 minutes. If you go over to 4 and go up to the P, draw a line. Does point P tell me the number of cakes? It would be 240, and that would be the total in 4 minutes. This is true. P is directly over 4. It's across from 240. This would be 240 over 4.
Yeah, that could simplify.
You could simplify and go to unit rate, which I think we'll get to in the next one. The number of cakes packed in 1 minute is 60. Go over to 1, go up to the next dots. Over to 1, up. Where is that dot in between? It's in between 40 and 80. Is between 40 and 80 really 60? Yeah, so this is also true. This is going to be 1, 60. Check that off. Last one, the number of cakes packed in 6 minutes is 400. Go over to 6. Go up. If this is at 400, this is also true. Is that y value 400? No, this is 360, so this is the only one that is false. 3 things that you're analyzing, draw a line to connect them. Next page. Yeah.